Hello everyone, welcome to the lecture again. In the last few lecture, we learned about how to find out the velocity and acceleration in different coordinate system. Today, we are going to study the equation of motion in different coordinate system. By equation of motion, I mean the Newton's second law. So, let me very briefly discuss what is Newton's law because we are already aware of that. So, Newton's law, the statement of the first law is following: a body moves with constant velocity which may be 0 also. So, that means the body is at rest unless acted on by a force. The implication of this law is, this law defines what is 0 force. So, it gives you the definition of 0 force, and very importantly it also gives you the definition of the inertial system. It gives a definition of an inertial system. Now, inertial system is that system in which the Newton's second law is applicable. Okay. So, let us look at the second law. It states that the time rate of change of the momentum of a body equals to the force acting on the body. So, F is nothing but dP by dt, and we know that momentum is m times v. So, this is d over dt m v, and let us say the mass is constant. In that case, we can write it down as m dv by dt, and dv by dt is the acceleration. So, therefore, it can be written as ma. So, either F equal to dP by dt, or you can say if the mass is constant, then F is equal to ma. Now, I am not elaborating more on this because we are already familiar with that. However, we are interested in writing this equation F equal to ma in different coordinate system. So, let me briefly state the third law also. So, this is something that we have extensively used when we studied the equilibrium. For every force on one body, there is an equal and opposite force on another body. Okay. And here I wrote F equal to ma when there are one force acting on a particle, but if there are many forces, then this equation can be generalized as summation of F equal to m and the acceleration because of all the forces. Okay. Now, let us write this down, F equal to m equation for different coordinate system. What are the coordinate system that we have studied so far? Are the Cartesian coordinate, planar polar coordinate, cylindrical coordinate, and spherical coordinate. So, let me write down this equation in those system. In Cartesian coordinate, we can decompose that equation, summation Fx equal to m x double dot, where x double dot is the acceleration along the x direction, and similarly summation Fy equal to m y double dot and summation Fz equal to m z double dot. In planar polar coordinate, we have the force along the r direction and theta direction, summation Fr equal to m, and then the acceleration along the r direction. This is something that we have derived, r double dot minus r theta dot square, and summation F theta equal to m acceleration along the theta direction, that is r theta double dot plus 2 r dot theta dot. In cylindrical coordinates, we have the r, phi and z axis. Therefore, summation F r equal to m r double dot minus r phi dot square, and summation F phi equal to m r phi double dot plus 2 r dot phi dot, and summation F z equal to m z double dot. In spherical coordinate system, we have r theta and phi axis. Therefore, summation F r is equal to m r double dot minus r theta dot square minus r sin square theta phi dot square, and summation F theta is equal to m r theta double dot plus 2 r dot theta dot minus r sin theta cos theta phi dot square, and summation F phi equal to m 2 r dot phi dot sin theta plus 2 r theta dot phi dot cos theta plus r sin theta phi double dot. These are the Newton's law in different coordinate systems in different direction. Now, with this very basic introduction, now let us look at the examples. The first problem statement is following. The 300 Newton block A is at rest on the horizontal plane when the force P is applied at t equal to 0 second. Find the velocity of the block when t is equal to 5 second, and it is given that the coefficient of static and kinetic friction are 0.2. Here it is obvious that the problem is easy to solve in Cartesian coordinate. Let me first make the free body diagram of this. So, we have a block, its weight is 300 Newton, and there is an external force that is acting at 30 degree with the horizontal. Its value is P equal to 200 Newton, and because of that this block is going to move. First of all, there will be a normal force, let us say N A, because this is A, and the frictional force will oppose the motion. So, therefore, they will develop in the opposite direction of the motion. So, let us say this is the frictional force. This completes the free body diagram. Now, let us write down the equation of motion in the x and y direction. So, in the x direction we have summation f x equal to m a. Let me call this equation number 1, and in the y direction there is no acceleration because the block is moving along the horizontal. Therefore, in the y direction the forces has to be balanced. So, summation Fy equal to 0, and the reason, as I said, because the motion is in x direction. Okay. So, from equation number 2 we can find out what is the value of Na, and therefore, I can find out what is the value of Fa because the frictional coefficients are given. So, let me use equation number 2 to find out what is Na. So, we can balance the forces along the y direction. So, we have Na equal to 300 plus 200 sine 30 degree. Therefore, Na is 300 plus 200 into half, which gives you 400 Newton. Therefore, the frictional force Fa will be mu times Na, and that will be 0.2 into 400 equal to 80 Newton. Now, I can use equation number 1 because now the Fa is also known and I know all the forces that are acting along the x direction. So, from equation number 1 we have Ma equal to total force along the x direction is P cos 30 degree minus 80 Newton. Therefore, A becomes P is 200, cos 30 is square root 3 by 2 minus 80 divided by the mass of the object. So, weight is 300. So, we have to divide it by 9.81 and this gives you 3.048 meter per second square. So, this is the acceleration. Now, we have to find out the velocity of the block. So, velocity we can find out v is equal to a dt. So, we integrate the acceleration with respect to time because dv by dt gives you a. So, since dv by dt is equal to a, therefore, v is integral a dt and it will be integral a we already know 3.048 into dt and this gives you 3.048 t plus c1. Let me call this equation number 3 because I have to find out what is c1. And x again I can find out by integrating v dt because v is nothing but dx by dt. So, v is dx by dt, therefore, x is integral v dt. So, it becomes 3.048 t plus c1 dt. So, it will be 1.524 t square because the integral of t is t square divided by 2 plus c1 t plus c2. Let me call it equation number 4. Now, the value of c1 and c2 I can find out using the initial condition, and let us say at x equal to 0 everything start. So, therefore, t is 0. Now, if I put x equal to 0 and t equal to 0 in equation number let us say 4, then I get c2 equal to 0. Okay. And since at this instant the initial velocity v is also 0, therefore, I get c1 equal to 0. Now, in the question statement we have been asked to find out the velocity when t is equal to 5 second. So, let us put t equal to 5 in equation number 3 and 4. So, we have v equal to 3.045 into 5 equal to 15.24 meter per second and x will be 1.524 into 5 square which is 38.1 meter. Note that we have put t is equal to 5 second in equation number 3 and 4. Now, let us look at another problem based on spring. The question statement is following: the block of mass m slides on a horizontal plane with negligible friction. The position coordinate x is measured from the undeformed position of the ideal spring of stiffness K. If the block is launched at x equal to 0, with the velocity v naught to the right, determine 1 the acceleration of the block as a function of x, the velocity of the block as a function of x, and the value of x when the block comes to rest for the first time. Okay. So, again this is a one dimensional problem and can be easily solved in Cartesian coordinate. Therefore, let us use summation f x equal to m x double dot, which is acceleration. So, let us say m a, and note that for a spring the force is equal to minus k times x, where x is the extension from the equilibrium and minus because it always opposes the extension. So, therefore, in place of f I can write down minus kx equal to m a. Therefore, the acceleration becomes minus k over m into x. Now, to find out the velocity, let us use the acceleration. So, a is dv by dt, let us multiply it by dx and divide by dx. So, dx by dt I can write down as v. So, acceleration can also be written as v dv by dx. So, for the second part, let me use this relation v dv by dx equal to the acceleration which we have find out minus k over m into x. Now, we can use the variable separable rule. So, we have v dv equal to minus k over m x dx, and let us integrate it. So, we have v square divided by 2 equal to minus k x square divided by 2 m plus a constant c. This constant I can find out from the initial condition. It is given that at x equal to 0 the velocity v is v naught. Therefore, I have c equal to v naught square divided by 2. Thus, I get v square divided by 2 equal to minus k x square over 2 m plus v naught square by 2, or v I can write down as plus minus square root k over m minus x square plus v naught square. In the third part, we have been asked the value of x when the blocks comes to rest for the first time. So, when the block comes to rest, that means v has to be 0. So, in part second, let us put v equal to 0. So, we have k x square over m equal to v square, or x equal to v naught square root m by k. Let us look at it by in picture. So, on the x axis, let us say I have x, and on the y axis I have v. At x equal to 0, its velocity is maxima, it is v naught given in the question, and at x equal to v naught square root m by k, its velocity is 0. And because of this equation v equal to square root minus k over m x square plus v square, it will be a ellipse. So, this is minus v naught, here this point is v naught square root m over k, and this point will be minus v naught square root m over k. Now, let us look at another problem based on projectile motion. The question statement is following: a projectile of weight W is launched from origin O. The initial velocity v naught makes an angle theta with the horizontal. The projectile lands at a distance r from O as measured along the inclined plane. And we have been asked the following: assuming v naught and theta are known, find the rectangular component of the velocity and position of the projectile as a function of time. And in the second part, we have been given the value of v naught and theta. So, given v naught equal to 20 meter per second and theta equal to 30 degree, determine the maximum height h and distance r. In this question, we have to use the rectangular or Cartesian coordinate, because in the problem statement itself we have been asked to find out the rectangular component of the velocity. So, let us use the Newton's law in the Cartesian coordinate. So, we have summation fx equal to m ax and summation fy equal to m ay. Note that there are no force acting along the x direction, the gravity acts along the y direction. Therefore, we have 0 equal to mass. The weight is given in the question, it is W. So, mass will be W by g to ax, and this gives you ax equal to 0, and summation fy equal to may gives you the weight will act in the minus y direction. So, minus W equal to W over g into ay. This gives you ay equal to minus g. This is something that we already know, that the acceleration will be g towards the ground, and in the x direction there is no acceleration. Now, let us use ax equal to 0. So, we have ax equal to 0. Therefore, Vx will be integral Ax dt, and since Ax is 0, it will be 0 plus C1. Now, x will be integral Vx dt, so it will be C1 dt, so that will be C1t plus C2. Similarly, a y is given as minus g, therefore, Vy will be integral Ay dt, so that will be integral minus g dt, that will be minus gt plus constant, let us say C3, and y will be integral Vy dt, so that will be integral gt plus C3 dt, that will be minus half gt square plus C3t plus C4. Now, we have to find out what are these constant C1, C2, C3 and C4 from the initial condition. Now, you know that at t equal to 0, x is 0 and y is also 0, because we have fixed our coordinate at x equal to 0, y equal to 0. And Vx at x equal to 0 is V naught cos theta and Vy is V naught sin theta. From here you can clearly see that C1 will be V naught cos theta and C2 will be 0, C3 will be V naught sin theta and C4 will be 0. Let us put in these equations. So, we get Vx equal to V naught cos theta, because Vx was C1 and C1 was V naught cos theta, and x comes out to be V naught cos theta into t, and Vy is minus gt plus V naught sin theta. Let us look at Vy. Vy was minus gt plus C3 and C3 was V naught sin theta. So, therefore, that becomes minus gt plus V naught sin theta, and y is minus half gt square plus V naught sin theta into t. This is the expression for the velocity and position of the projectile as a function of time. Now, let us put the value V naught equal to 20 meter per second and theta equal to 30 degree to determine the maximum height h and the distance r. So, let us put V naught equal to 20 meter per second and theta equal to 30 degree. So, we get Vx equal to V naught cos theta, V naught and theta is given, this comes out to be 17.32 meter per second. Similarly, Vy comes out to be minus 9.8 t plus 10 meter per second, and x comes out to be 17 minus 32 t meter, and y comes out to be minus 4.905 t square plus 10 t meter. Now, in the question statement, we have been asked to find out the maximum height. We know that at the maximum height, its vertical velocity is going to be 0. So, let us put Vy equal to 0 and find out the time that it takes to reach the maximum height. So, let us put Vy equal to 0 for maximum height. We have Vy equal to 0. So, we have 0 equal to minus 9.8. Let us say it takes a time t1 to attain the maximum height. So, plus 10, this gives you t1 equal to 1.02 second. Now, to find out the maximum height y max, let us use that equation because now t is known. So, y max becomes minus 4.905 into 1.02 square plus 10 into 1.02, and that gives you 5.09 meter. In the problem statement, we have been also asked to find out the distance r. So, therefore, let us say the coordinate of point A is x and y, then x and y I can write down in terms of r, because this length is 4, then this length is 3, it is given. So, therefore, x will be 4 divided by 5 r and y will be minus 3 by 5 r. Now, let us put this value of x and y in this and this equation. So, we have 4 by 5 r equal to 17.32, and let us say the time that it takes to reach at point A is T2. So, it will be T2. Similarly, minus 3 by 5 r is minus 4.905 T2 square plus 10 T2. And these are two equations and there are two unknown r and T2. So, you can solve equation number 1 and 2, and this gives you T2 equal to 2.57 second and r equal to 55.6 meter. So, with this let me stop here. See you in the next class. Thank you.